Okay, so this video focuses on adding fractions with unlike denominators. So I know I can add my fractions together when the same number is on bottom. So I have a common denominator. And I can add the two top numbers, the two numerators to get the sum, and then I keep the denominator the same. But what happens if the number on bottom is different? So we are going to look at three different methods to add these unlike denominator fractions together. So the first scenario is using lowest common multiple to find the lowest common denominator. Now, I've already done a video on lowest common multiple, or LCM, so I'm not going to explain everything about that process, but I am going to demonstrate the process for you. So essentially for LCM, I'm going to take my first denominator, and I'm going to take my second denominator, and I'm going to list out my multiples. So I'm going to skip count by 6, 12, 18, 24, and then I'm going to skip count by 9, 18, and I'm actually going to stop there because the lowest common denominator, or the lowest common multiple, is 18. So that means when I rewrite my fractions, I will have them out of 18. So now I'm going to take 3 over 6 and I'm going to multiply by 3. 3 times 3 is 9. And then 3 times 6 is what gives me the 18 that I've already said is my common denominator. For my second fraction, 2 over 9, I'm going to multiply by 2. And that will give me 4 over 18. So my final answer ends up being 13 over 18. Since 13 is a prime number, I have finished solving my equation. So another method that I can use, if maybe it's taking me a really long time to skip count, or maybe I just really don't want to skip count, I can multiply each fraction by the opposite denominator, or the other denominator. So in this example, we have 3 over 8 plus 2 over 9. So what I'm going to do is take 3 over 8, and I'm going to multiply by 9, the other denominator. And then I'm going to take my second fraction, 2 over 9, and I'm going to multiply by my 8, the other denominator. And this will help me create equivalent fractions with common denominators. So 9 multiplied by 3 is 27. And then 9 multiplied by 8 is 72. For my second fraction, 2 multiplied by 8 is 16. And then 9 multiplied by 8 is 72. All right, now that I have found a common denominator by using the opposite denominators, I'm going to add together my numerator, so 27 plus 16. And if I, don't really know the answer to that, I could always do my workings over here. So 27 and 16. 6 plus 7 is 13. 2 plus 1 is 4, so 43 over 72. And then I need to consider whether or not this fraction can be reduced, and it cannot. So my final answer is 43 over 72. So the last method isn't really a method at all. It's basically just using your number sense, so your understanding of mathematics, your knowledge about certain math facts, to solve the problem. You can't do it all in your head. I still need to see certain steps, but for a lot of it, if you are just logically processing it, that's cool too. So if I look at 4 over 6 plus 2 over 3, I have number sense that tells me that I can simply change one of my fractions. So I can take 2 over 3 and multiply by 2. So my first fraction I don't need to change. I have 4 over 6. For my second fraction, I was able to recognize that with a denominator of 3, I could quickly make it a denominator of 6 simply by doubling it. So it just cut out the step of having to list out my multiples. So my second fraction also turns out to be 4 over 6. So 4 over 6 plus 4 over 6 actually equals 8 over 6, which causes me a little bit of trouble. It's an improper fraction. So I'm going to ask myself how many 6s to make 8, or how many groups of 6s. So I need one full group of 6s to make 8, with 2 left over 6. Now, I can reduce this. My whole number will stay the same, but 2 over 6, they're both even numbers, so I can divide by 2. I end up with 1 1/3. So as you can see, I used number sense to process this problem, but I still showed a lot of my workings. What I would like to see is something like this here, where you're showing me what you are multiplying by. I do think it is an important step to rewrite your fractions, and then you can show me your final answer. Okay, so if you are reducing, I don't necessarily need to see that step, but I do need to see the reduced answer at the end. So let's just do one more example, just processing it logically using some of our number sense. I have 6 over 24 plus 1 over 7. Okay, so the second one is a little more complicated. So I'm just going to kind of talk you through how I would approach this problem if I wasn't using one of my other methods. So I know 6 over 24 can be reduced, and I know that that is actually representing a quarter, 1 over 4. So I was able to do that, like I said, using my number sense. It was a mathematical process I could complete inside my brain. Some of us need to write it out, and that is absolutely perfect, okay? So now I have 1 over 4 plus 1 over 7, and my problem gets much, much easier because I know 4 times 7 is 28, and then 1 times 7 would have given me 7, so 7 over 28. I'll write that down. I'm multiplying by the opposite denominator. So I am using mathematical processing, but I do just want you to know what I'm doing here. So 7 over 28 plus 4 over 28. And now I can add. So 7 plus 4 ends up giving me 11 over 28. 11 is a prime number. So I have finished this problem. Okay, so here you have 3 different ways to go about adding fractions with unlike denominators. If you have another method that you use and you are still able to get the correct answer, feel free to use it as long as you're highlighting your key steps. Happy studying and good luck.